This video will focus on Archimedes' principle and the concepts of floating and sinking. Archimedes, an eminent Greek mathematician and inventor from 287 to 212 BC, contributed significant works to geometry, arithmetic, and mechanics. Archimedes' principle is a law of physics stating that an object immersed in a fluid experiences an upthrust equal to the weight of the fluid displaced. This principle explains floating, sinking, and why objects feel lighter in water. It also applies to balloons in the air. The key term is upthrust, or buoyant force, which is the upward force that reduces the object's weight underwater. For instance, a 100 cubic centimeter metal block displaces an equal volume of water, which weighs about 1 Newton. This makes the block appear 1 Newton lighter in water. Here we compare the weight of an aluminum block in air and when it is immersed in water. In air, the spring balance reads 2.7 newtons. In water, the reading is 1.7 newtons. The buoyant force is the difference between these two readings. For a block of wood, since it floats, the spring balance reading when submerged is 0. This is because the upthrust perfectly balances the weight of the wood. From Archimedes' principle, the buoyant force equals the weight of the fluid displaced, which is also equal to the density of the fluid times the volume of the fluid displaced, or volume of the object immersed times the gravitational acceleration. Buoyant force determines an object's movement in a fluid. If the buoyant force equals the weight, the object floats and is stationary. If the buoyant force is greater than the weight, the object moves up. If it is less, the object moves down. The law of flotation states that a floating object displaces its own weight of the fluid in which it floats. For a ship, the total mass of the ship plus its cargo equals the mass of the water displaced to allow it to float. This is how displacement is measured for large vessels. Consider why a ship's immersion depth changes in different water types. The difference is due to the water's density. Fresh water is less dense than seawater, and warm water is less dense than cold water. Therefore, warm, fresh water requires more volume to be displaced to generate the same upthrust needed to keep the boat afloat. Next, let's explore why plasticine sinks as a ball but floats when formed into a hull shape. When shaped as a ball, the displaced water weighs less than the ball. When formed as a hull, the larger volume displaced means the weight of the displaced water equals the hull's weight, allowing it to float. Archimedes' principle applies to hot air balloons. The balloon rises if the upthrust is greater than the total weight. It descends if the upthrust is less, and it is stationary if they are equal. The Plimsoll line marked on a ship's body guides safe loading limits, as the density of seawater changes with location and season. This line shows different immersion limits for various water conditions. Submarines use ballast tanks to control their buoyancy. Empty ballast tanks mean upthrust is greater than weight, causing the submarine to rise. Full tanks mean upthrust is less than weight, causing it to sink. A hydrometer is an instrument used to measure the density of a liquid. It floats upright due to the lead shot. It sinks deeper in liquids of lesser density and floats higher in liquids of higher density. Let's look at an example. A rock weighs 0.85 newtons in air and 0.45 newtons submerged in water. The buoyant force is calculated as the actual weight minus the apparent weight, which equals 0.4 newtons. In this problem, a concrete slab with an actual weight of 180 newtons has an apparent weight of 105 newtons when fully submerged. The buoyant force is 75 newtons. Using Archimedes' principle, the buoyant force equals the weight of the displaced seawater. Given the volume and using the formula F equals PVG, we can solve for the density P, which is 1,530.61 kilograms per cubic meter. This concludes the video on floating and sinking principles. Thank you for watching.